Hello everyone, and welcome back to Geminic Science. Today we are diving into a fascinating problem that combines both physics and engineering. So let's imagine you are trying to figure out how far a signal can be seen clearly in a foggy condition. And when we say a foggy condition, this is simply when you can't see very far because of a thick cloud-like air close to the ground. Or you can choose to put it differently by saying a fog. This is simply a meteorological phenomenon which is being characterized by the presence of water or cloud in the air. Notice that this is a real-world problems or challenges that engineers faces when designing a communication system. And you need to understand that the problem involves using a dimensional analysis to determine the distance over which a signal can be seen clearly, and we're going to consider some basic factors like the frequency of the signal, the density of the photons, and the intensity of the light from the signal. Our goal is simply to drive an equation that shows how these variables are related to the visibility distance. So let's assume we are given this kind of problem which says a Gideon Robert University Railway Engineering student uses dimensional analysis to find the distance over which a signal can be seen clearly in foggy conditions. And it continues by saying the student assumes that the distance depends on the frequency of the signal and the density, which is being denoted by rho, of the fog, and the intensity of the light from the signal. And the question here is for us to show that D is equals to K, which is constant 1 divided by the frequency divided by 3 into the square root of I, which is the intensity divided by the density. So how can we solve this problem? Notice that to solve this problem using dimensional analysis, we simply need to determine how the distance d over which the signal can be seen clearly in the foggy condition depend on the frequency of the signal, the density of the fog, and the intensity of the light. When we talk about intensity which is being denoted by I, this is simply going to be power divided by unit area, or intensity, which is simply going to be P divided by A. Let's assume that the first thing which we need to do is to simply assume that the distance can be expressed as D, which is K, multiplied by F, multiplied by rho, multiplied by our intensity. And notice that the K is simply dimensionless constant and proportionality, and A, B, and C are exponent to be determined. So we're going to put the A here, B, and C. I'm going to repeat that. A, B, and C are the exponent which we are going to determine. And we said this is dimensionless constant, which we are going to neglect that. So what we're going to be left with at this point is going to be D, which is equal to F. Let's put it in frequency. F A multiplied by rho B, which is the density, multiplied by the intensity to the power of C. So at this point, first thing which we need to do is to identify the dimensions of each, values here. Starting with the first one, which is the frequency. So for the frequency, the dimension for the frequency is going to be T to the power of -1. And the dimension of density, this is simply going to be ml to the power of -3. What about the dimension of the intensity? For the intensity, this is going to be mt -3. Notice that this is ml, this is mt, and that's the difference. So now we can rewrite the dimension. What about distance? The dimension for distance is simply going to be length, isn't it? So at this point, we're going to have L equals to the dimension for frequency, which is what T -1. Remember, the frequency have exponent of A, which we are going to put the A here. So we're going to multiply that by bracket of the density. And what we have as density, which is ml negative of 3. And remember, the exponent which you have for this is going to be b. The last but not the least, which is the intensity, which is going to be the bracket of mt negative 3. And here we're going to have our exponent to be c. So what are we supposed to do at this point is to simply expand the right hand side. The right hand side starting from the t to the power of negative 1 multiplied by a, ml negative 3 multiplied by b, mt negative 3 multiplied by c. In this case, negative 1 multiplied by a is simply going to be negative a, which this side is going to be the bracket of t negative a. We're going to multiply that by bracket of m multiplied by b is going to be mb. Then L to the power of negative 3 multiplied by b is simply going to be L negative 3b. Close the bracket and multiply the last one, which is going to be m to the power of c, and t to the power of negative 3 multiplied by c is going to be L minus 3c, and you close the bracket. To make it easier, let's write it below. The continuation of this is going to be the bracket of m to the power of c, t minus 3c. So at this point, what we need to do is to simply combine the like terms. What we have is m, and we also have l, and we also have t. That is from the right hand side. From the left hand side, the only thing which we have is l. And notice that we are considering the left hand side this time. So how many m do we have in this problem? Starting from this. Let me highlight it. For these three problems, the numbers of L which we have is going to be 2. What about L? L is going to be 1 and T is going to be 2. So notice that M, what do we have in the first M? We have B. And what do we have in the second M? We have C. This is simply going to be B plus C. So for the L is 1. And what we have on top of L is simply negative 3B. The last but not the least, which is T. And how many T do we have is 2. The first T is going to be negative 1, negative A, I mean. And the second T is going to be negative 3B. So if you have something like this, you can simply set up an equation, which is going to be M, which simply stands for our mass. Let's put it this way. Our mass into bracket of M. And what we have, this is going to be B plus C. And the next thing which we have is the length. For the length which we have as L, this is simply going to be negative 3B. And the last but not the least, which is T, which is time. This is going to be T, which is going to be negative A, negative 3B. So what are we going to do next at this point? So we can define the whole equation. Okay, before then, let's call this to be our equation 1, and this to be our equation 2, and the last but not the least, which is for the time, to be our equation 3. So to make things very easy, let's wipe up this so that we can have space for other calculations. What we are supposed to do, check the shortest one. The shortest one is the length. So let's define the equation 2. We said length, which is L, is simply given to us as negative 3B, which this, because of the negative, is going to be 0. So let's make B to be our subject of the formula by bringing, it's not, because of negative is going to be 1. Making B to be our subject of the formula, here we have negative closer to the 3. If we bring it this side, it's going to be positive. B is going to be 1 divided by 3. It has turned to positive. So I needed to find a space like this and write B is going to be 1 divided by 3. Next thing which you have is mass. Let's take mass to be equal to M, which is going to be B plus C. And this is positive, is going to be 0. So notice that what we need to do at this point is to make C to be the center of our formula. If we bring B here, it's going to be negative. So meaning that C is equal to negative B. So what is B? B is 1 divided by 3. So C is going to be negative 1 divided by 3. At this point, we can say that our C is simply going to be negative 1 divided by 3. So the only thing which we're going to be left with is time, which is T. Our time is going to be negative A, negative 3B. Let me use another color. We said our time is going to be negative A, negative 3B, which this one also is going to be negative, negative, positive is going to be 0. So negative A minus 3, what is the value of B? B is 1 divided by 3, which is simply going to be 0. This will cancel out. Negative, negative is going to be positive. So let me delete these guys here. Continuation of the time. So this guy here, we're going to be left with A plus 1, which is going to be 0. Making A to be the subject of the formula, A is going to be negative 1. So therefore, our B is 1 divided by 3, C is negative 1 divided by 3, and A is going to be negative 1. So remember, from the assumption which we have, we said our D is simply going to be K. We're going to multiply that by frequency to the power of A, which we're going to multiply that by our density to the power of B, which we will also multiply that by our intensity to the power of C. And we continue to say, which is the same thing as saying D is simply going to be F to the power of A multiplied by the density to the power of B multiplied by the intensity to the power of C. So what we need to do at this point is to simply replace. What is A? A is negative 1. Our density is length, which is going to be F to the power of negative 1. Multiplied by our density to the power of B, and B is 1 divided by 3. Negative 1 divided by 3. Multiplied by our intensity, which is going to be 1 divided by 3. So our L is going to be 1 divided by frequency, which is the same thing as saying F to the power of negative 1. Here we have density, here we have intensity. We're going to put everything in bracket, which is going to be the intensity divided by the density. What we have in common is negative, is 1 divided by 3, 1 divided by 3, multiplied by the negative, which is going to be negative 1 divided by 3. Which, if we bring it down up here, we're going to have our 3. So this is it for this problem. If you noticed, what we are given from the beginning of the equation is this. We are given to say D is equal to the dimensionless, right? Multiply by 1 divided by frequency into bracket of 3 to the square root of I divided by the density. Therefore, this is equals to this. So this is it for this problem. I hope you find it very helpful. Please, if you do, don't forget to just do me a favor by subscribing to Geometric Science. Thank you for watching, and see you next. Hello everyone.